The Grumman F8F Bearcat arrived too late to participate in combat during the Second World War. Nevertheless, it stands as one of the aircraft representing the zenith of piston-powered fighter design, which emerged just as the war concluded. It is crucial to note that the Bearcat was not an incremental improvement upon previous Grumman fighters like the Wildcat or Hellcat. Instead, it represented a fundamentally new design differing vastly from the Hellcat in both design philosophy and execution. Grumman's preceding fighter, the F6F Hellcat, was a relatively low-cost aircraft by the standards of American World War II fighters designed for rapid and inexpensive production. This is not to detract from the Hellcat's quality. It was a formidable aircraft. However, certain performance characteristics were compromised in the interest of streamlining assembly line time and reducing costs. The strategy proved highly effective. Initially priced at approximately $50,000 per unit, which was a considerable value, the cost of a Hellcat quickly fell to around $35,000 as production became more efficient. This price point was achieved at a time when contemporaries like the Wartime F4U Corsair and Republic P-47 Thunderbolt cost more than double that amount. In terms of value per dollar, the Hellcat was arguably the best American fighter of the war. Not necessarily the most capable overall, but the most cost-effective. Notably, by 1944, even a Curtiss P-40 Warhawk cost more than a Hellcat despite the Hellcat's vastly superior capabilities. The Bearcat, however, was a different matter entirely. With a unit cost of approximately $83,000, it was even more expensive than the famously complex and difficult-to-build Corsair. The Bearcat's development arguably represented a new direction in warplane economics for Grumman. The fundamental equation in military procurement, quantity versus quality, provides a framework for understanding this shift. The choice is often between acquiring a few highly expensive top-tier aircraft or a larger number of less expensive but also less capable ones. There are scenarios where a greater quantity of slightly inferior aircraft is the strategically sound decision, especially if the added expense provides capabilities that are not required for the intended operational environment. For instance, while the P-47 Thunderbolt was more than twice the price of a Hellcat, it offered significantly better high-altitude performance and greater range. A key question arises from this comparison in a low-altitude combat environment like the Eastern Front, where engagements are typically close to the front lines. Would a commander prefer 8 Hellcats or 4 Thunderbolts? The answer, assuming sufficient pilots are available, would unequivocally be the 8 Hellcats. However, the dynamics of aircraft carrier warfare present a different set of constraints. A carrier can only accommodate a finite number of aircraft. In this context, the question becomes, is it preferable to have 20 of the most capable fighters available to counter incoming threats, or 20 slightly inferior aircraft? The answer is self-evident. With the emerging threat of kamikaze attacks, every second of combat performance became critical. It appears Grumman shifted its design philosophy towards producing more expensive, higher-performance fighters, a trend that continued for as long as the company manufactured fighter aircraft. This line of thinking culminated in the F-14 Tomcat, which was at least 3 times more expensive than the F-4 Phantom. It largely replaced in the fleet air defense role. Some estimates place the Tomcat's cost at 10 times that of the Phantom. Though these figures can be difficult to verify and may be skewed by comprehensive export packages such as the one sold to Iran, which included more than just the aircraft. Regardless, the Tomcat was exceptionally expensive, but its cost becomes more understandable when considering the critical nature of its mission, defending the fleet from incoming threats. Due to the spatial limitations of an aircraft carrier, launching 3 times as many F-4 Phantoms or F-8 Crusaders was simply not a viable option. As Grumman specialized in carrier-based aircraft, this quality over quantity philosophy seems to have guided their development, beginning with the F8F Bearcat. Furthermore, by the time the Bearcat's development was well underway, Grumman was likely considering post-war markets. It is plausible they anticipated a significant reduction in military aircraft sales in a peacetime environment, making it economically prudent to focus on selling fewer, more expensive aircraft. History demonstrates that among the American companies that produced combat aircraft during World War II, Grumman was one of the most financially successful in the post-war era, suggesting their strategic shift was a well-calculated business decision. Turning to the aircraft's design period, publications suggested the new Bearcat combined the best features of Japanese fighters with those of U.S. Navy fighters. Although the Bearcat was not frequently mentioned in these publications, as the excitement had largely shifted to the emerging jet aircraft when it was discussed, a Japanese design influence was often noted. While there was some Japanese influence, stronger parallels can be drawn with German fighters and the Vought F4U Corsair. Grumman did not operate in a design vacuum. The company prudently studied aircraft from its competitors. Grumman engineers had opportunities to closely inspect the Mitsubishi A6M, the Focke-Wulf FW190, and of course the Corsair. While some of these detailed inspections may have occurred after the Bearcat's design work had commenced, it does not preclude Grumman's engineers from having prior exposure or from incorporating new findings during the development process. The inspiration for the Bearcat is famously attributed to a conversation between acclaimed naval aviator Commander John Jimmy Thack and a Grumman vice president. Thack emphasized that a high rate of climb was of paramount importance for a carrier-based fighter, a principle that Grumman clearly prioritized in the Bearcat's design. An aircraft's maximum rate of climb is a function of the difference between power available and power required. At the time of the Bearcat's development, the most powerful engine available to Grumman was the Pratt & Whitney R2800 Double Wasp, the same engine used in the Hellcat and Corsair. Therefore, a significant increase in available power over these existing aircraft was unlikely. Even if a newer, more powerful variant of the R2800 were used, that same variant could likely be fitted to the other aircraft as well, negating any distinct advantage for the Bearcat. This left Grumman to focus on reducing the power required for flight. The most effective way to achieve this was by reducing the aircraft's weight. As all aircraft designs are a series of compromises, the question became what Grumman was willing to sacrifice to minimize weight. Armor was not compromised. In fact, the Bearcat was equipped with armor capable of stopping a .50 caliber round, making it one of the few World War II fighters with such robust protection. Self-sealing fuel tanks, which add considerable weight, were deemed a necessary performance sacrifice based on wartime combat experience, especially given the widespread use of incendiary and explosive ammunition. The Bearcat was equipped with a self-sealing tank, but only a single 185-gallon main fuel tank. This limited fuel capacity had significant operational implications. For a fleet defense mission, a Bearcat would consume approximately 5 gallons per minute, 300 gallons per hour on takeoff and initial climb. Shortly after, at maximum continuous power, fuel burn would be around 170 gallons per hour, with spikes up to 280 to 300 gallons per hour at war emergency power. Consequently, on internal fuel alone, a Bearcat in this role had an endurance of only about 45 minutes before the pilot had to seriously consider returning to the carrier. While loitering at altitude, the pilot could extend this endurance by throttling back significantly, flying at an economical speed, and manually leaning the fuel mixture, bringing fuel flow down to the 40 to 45 gallon per hour range. Despite these mitigation techniques, the Bearcat's range was a major step back from the Corsair and Hellcat, bearing a closer resemblance to early models of the Messerschmitt Bf 109. This was a deliberate sacrifice to achieve the desired performance. While not explicitly a result of German influence, the philosophy of a smaller short-range interceptor was very much aligned with German design practices. The Bearcat's range could be extended with drop tanks, but these are jettisoned in combat, meaning the aircraft's maximum combat radius is ultimately limited by its internal fuel capacity. This is why late-war P-47 Thunderbolts carried 370 gallons of internal fuel, with the N model carrying even more. The Bearcat burned fuel at a similar rate but had only half the internal capacity, a significant limitation. To further reduce weight, the aircraft was simply made smaller. The Bearcat is more than 5 feet shorter than both the Hellcat and Corsair and has a considerably smaller wingspan. This reduced size contributed to its lower weight, though it also inherently limited the space available for fuel. For comparison with European fighters, while no proven navalized German fighters existed for a direct parallel, the few Bf 109T models notwithstanding, the Bearcat and FW190 are quite close in length and wingspan. The Bf 109 is slightly smaller but in the same class. Thus, while the Bearcat's dimensions were small for an American fighter, they were comparable to those of its German counterparts. German fighters were lighter, but this is largely because they were not designed for carrier operations and lacked folding wings, arresting gear, and the reinforced structure needed to withstand catapult launches and arrested landings. A relevant British contemporary is the Supermarine Seafire FR-47, a true superprop. This aircraft was significantly faster than the Bearcat. While heavy by Spitfire standards, this version was equipped with a Rolls-Royce Griffon engine, dual contra-rotating propellers, and hydraulically powered folding wings along with other naval equipment. The Bearcat remained the lightest of these naval fighters, not much heavier than the land-based FW-190A8. This low weight was achieved through its size and several other more surprising methods. One of these methods was particularly radical. Before delving into that, an examination of the engines is warranted. The Bearcat utilized two primary engine variants. The F8F1 models were generally fitted with the R2800 34W, while the F8F2 models used the R2800 30W. Confusingly, the later aircraft used the lower dash number engine. The R2800 34W in the early F8F1 was the latest evolution of the R2800 series at the time and was a rare engine used almost exclusively in the Bearcat. It produced two 300 horsepower at 58 inches of manifold pressure and two 800 revolutions per minute. This power output was achievable without water injection, a notable advancement over earlier R2800 models in P-47s, which required water injection to reach similar power levels. When engaged in war, emergency power termed combat power by the Navy, the water injection system is activated, allowing up to 70 inches of manifold pressure and generating approximately 2,750 horsepower. This power increase resulted in a dramatic boost in speed. The key to weight savings in the Bearcat's power plant was not the engine itself but what was omitted. The Bearcat has no second-stage supercharger and its associated drive mechanism. This might seem like a step backward, as two-stage supercharging was standard on high-performance fighters like the Hellcat, Corsair, Spitfire, Mk-9, and Thunderbolt by 1945. However, by 1943, it had become clear that nearly all naval air combat occurred below 20,000 feet, as attacking aircraft had to descend to engage ships. The need for high-altitude performance in a naval fighter had diminished. The initial concern that high-altitude level bombers would attack fleets had not materialized. Therefore, Grumman eliminated the weight and complexity of a second-stage system that would rarely, if ever, be used in the aircraft's intended role. Without a second stage, there is no need for an intercooler, which is defined as a charged air cooler placed between supercharger stages. The Bearcat also lacks an aftercooler. This entire system was replaced by a robust water injection system fed from a 16-gallon tank. The performance charts illustrate the effectiveness of this design. At sea level, the F8F1 could achieve 331 knots at combat power and an impressive 366 knots at war emergency power with water injection engaged. This made it exceptionally fast for a propeller-driven aircraft at low altitude. As the aircraft climbed, power would decrease. At approximately 12,000 to 13,000 feet, the pilot would switch the single-stage supercharger to its high-speed gear. Above 20,000 feet, power dropped below 1,500 horsepower. Despite this, the Bearcat was still respectably fast at 25,000 feet, capable of 365 knots, but it was clear the aircraft was optimized as a low-altitude interceptor. Below 15,000 feet, it was a formidable machine. Aerodynamic refinement also contributed to its speed. The preceding Hellcat was built for ease of construction, featuring many flat panels and raised rivets. In contrast, the Bearcat, much like the Corsair, was flush-riveted and spot-welded across its entire airframe, resulting in a very smooth low-drag finish. This increased production cost but was a necessary step to extract maximum performance. The Bearcat also adopted the Corsair's more efficient method of routing air for the carburetor and oil coolers through inlets in the wing roots rather than the Hellcat's drag-inducing cowl inlets. Since the Bearcat had no intercoolers, these inlets could be made smaller, further reducing drag. At low altitude, where the penalty for cooling drag is highest, the Bearcat's water injection system provided the necessary anti-detonation protection without the parasitic drag of an intercooler system. Other weight-saving measures included the use of smaller, lighter wheel brakes, Carrier aircraft rely primarily on arresting gear for stopping, allowing for less robust brakes. However, this may have been taken too far, as Bearcats were known to suffer from brake fire, suggesting the brakes were undersized. The most extreme weight-saving technique, however, was in the wing design. To create a lightweight structure, the Bearcat's wings were built to a lower G-load limit than was typical. The pilot's manual indicates a maximum load of approximately 6.3 Gs. Some sources cite 7.5 Gs, whereas most contemporary fighters could withstand 9 Gs or more. The limit was further reduced to a mere 4.5 Gs if the ailerons were deflected during the maneuver. This significantly hampered the Bearcat's high-speed turning performance, making it vulnerable in maneuvering combat against nearly any other World War II-era fighter at speeds above 250 knots. Grumman's solution to pilots potentially exceeding these low G limits was highly unconventional. The company designed the wings so that the outer wingtips would break off cleanly in an over-G situation. In theory, this would leave the aircraft with sufficient wing area and aileron control to return to base. However, the realities of flight mechanics meant the tips did not always detach simultaneously. A single detached wingtip rendered the aircraft extremely difficult, if not impossible, to control. These failures often occurred during pullouts from low-altitude dives, leaving the pilot no time to recover. A fatal crash involving a Blue Angels Bearcat in 1946 was attributed to such a failure. Grumman's subsequent response was to install explosive charges linked between the wingtips, designed to ensure symmetrical separation. This solution also proved unreliable and dangerous, culminating in an incident where the explosives detonated while an aircraft was parked on the ground, killing a nearby crewman. Ultimately, Grumman abandoned the breakaway concept, strengthened the wings, and raised the G limit to a more conventional 7.5 Gs. This fix added approximately 250 pounds to the aircraft's weight. The Bearcat's most outstanding performance characteristic was its rate of climb. Early F8F1 models could climb at 500-600 feet per minute at sea level. For a decade, the Bearcat held the time to climb record to 10,000 feet, achieving it in 94 seconds from a standing start. This equates to an average climb rate of 600-400 feet per minute. This record was likely set by a specially prepared aircraft, possibly a civilian Gulf Hawk version of the Bearcat, stripped of its armor guns and self-sealing fuel tank. Early jet fighters struggled to beat this record because their engines produced maximum thrust and thus power at high airspeeds. A propeller aircraft like the Bearcat achieves its best rate of climb at a relatively low airspeed, allowing it to begin its ascent almost immediately after takeoff. A jet must spend considerable time accelerating on the level to reach its optimal climb speed, by which point the Bearcat had already reached the 10,000-foot mark. The later F8F2 variant introduced several upgrades. These models were generally equipped with 4 20mm cannons instead of the earlier 450 caliber machine guns, a significant increase in firepower. The F8F2 also featured a taller vertical stabilizer and rudder to handle the new armament's recoil. It is widely presumed that all F8F2s were built from the factory with the strengthened wing design. The most significant change in the F8F2 was the Pratt & Whitney R2800 30-Delve engine. This engine retained the single-stage supercharger and water injection, but replaced the two-speed drive with a variable-speed hydraulic drive unit. Some F8F2s were also equipped with an automatic engine control AEC unit, similar in principle to German engine management systems. The AEC reduced pilot workload by automatically adjusting the supercharger speed to maintain a set manifold pressure during climbs or descents, among other functions. This technology was analogous to the system used on the Bf-109. The F8F2's engine produced two 500 horsepower at war emergency power, 250 horsepower less than the F8F1. However, the variable speed supercharger provided more consistent power throughout the aircraft's altitude envelope. When comparing their speeds, the lighter, more powerful F8F1 was faster below 9,000 feet. Above that altitude, the F8F2's more efficient supercharger gave it a clear advantage. In summary, the Bearcat was influenced by a variety of design philosophies. The focus on low-weight, echoed Japanese designs, while its construction techniques and aerodynamic cleanliness were reminiscent of the Corsair. Its powerplant concept, a single-stage variable-speed supercharger with water injection instead of charge cooling, was remarkably similar to that of the Bf-109. The aircraft was a superb interceptor, one of the first true superprops, with incredible climb performance and speed below 20,000 feet. However, its design involved significant compromises, particularly in range and structural limits. The Bearcat's primary American rival was the Vought F4U Corsair, which remained in production 3 years longer until 1952. A comparison with the F4U-5 Corsair, introduced in late 1945, is telling. The F4U-5 was equipped with an R2800 32W engine, which featured a two-stage intercooled supercharger with a variable speed drive. This advanced powerplant allowed the Corsair to outperform the Bearcat at nearly all altitudes except for a narrow window below 6,000 feet where the F8F1 held a slight edge. Furthermore, the Corsair carried a far greater ordnance load, had significantly more range, and featured a much improved cockpit layout in its later variants. Even the older Hellcats were retained in service alongside the Bearcats due to the latter's range limitations. While the F8F Bearcat was a remarkable aircraft and one of the first superprops, its highly specialized design meant it could not compete with the all-around capability of contemporary Corsairs. Grumman, however, would soon introduce another formidable piston-engine contender to the arena, just as the British were developing several of their own. Unlike American forces, several Southeast Asian nations operated the F8F Bearcat in actual combat conditions, marking the aircraft's first and only wartime service. In 1951, the French Air Force ordered 200 F8F Bearcats for operations in Indochina. Upon acquisition, French forces immediately repurposed these carrier-designed interceptors for ground attack missions. This adaptation stemmed primarily from economic considerations. The United States offered these surplus aircraft at bargain basement prices as they were being phased out of naval service. French Bearcats faced numerous operational challenges in Southeast Asia. The Navy standard tires designed for carrier decks frequently blew out on rough jungle airstrips. Moreover, engines often ingested dirt and grass, causing maintenance difficulties. Despite these issues, 6 French fighter squadrons flew Bearcats extensively throughout Indochina. Armed with HVR rockets, bombs, and 20mm cannons, French Bearcats proved effective in ground support roles. Napalm became their standard weapon by 1952. Throughout their service, French forces lost 50 Bearcats, none in air-to-air combat, but approximately 1/5 through accidents or crashes. After the 1954 French withdrawal from Indochina, approximately 70 surviving Bearcats transferred to the newly formed South Vietnamese Air Force. From this inventory, 28 operational aircraft equipped the VNAF's 1st Fighter Squadron. South Vietnamese pilots continued using Bearcats primarily for ground attack missions until 1960, when they began phasing them out in favor of Douglas A-1 Sky Raiders and North American T-28 Trojans. The last VNF Bearcat retired from service in 1964. Simultaneously, Thailand built the region's largest Bearcat fleet. The Royal Thai Air Force purchased 129 F8F Bearcats in 1951, later acquiring an additional 75 aircraft, including 38 third-hand from France, totaling 204 aircraft. Designated Type 15 fighter by Thai forces, the first 40 Bearcats arrived aboard USS Cape Esperance and became operational in late 1951. Thai pilots immediately embraced the aircraft, deploying it both as an air defense interceptor and ground attack platform. The Thai Bearcats were officially retired between 1960 and 1962. Interestingly, unofficial reports from U.S. Air Force personnel suggest at least one Bearcat remained flying off the books as late as 1972, potentially supporting special operations. Among elite warbirds, the Grumman F8F Bearcat stands out not merely for its impressive specifications, but for the genuine affection pilots developed for this remarkable aircraft. From naval aviators to test pilots, the consensus was clear: the Bearcat offered a flying experience few other aircraft could match. Before his historic lunar mission, Neil Armstrong flew the F8F extensively as a naval aviator. He consistently ranked the Bearcat as his favorite piston-engine fighter, noting its exceptional responsiveness and intuitive handling characteristics. "The Bearcat gave you confidence from the moment you settled into the cockpit," Armstrong remarked after transitioning to test pilot duties. This future moonwalker frequently described the Grumman Bearcat as having near-perfect harmony between controls and a natural feel that made complex maneuvers seem effortless. Armstrong was not alone in his assessment. Renowned test pilot Corky Meyer declared it the best handling and performing carrier-based fighter I have ever flown, highlighting how the aircraft seemed to anticipate pilot inputs before they were fully executed. This quality and almost symbiotic relationship between aircraft and aviator became the Bearcat's defining characteristic among those fortunate enough to fly it. Beyond straight-line performance, the Bearcat fighter excelled precisely where pilots needed reliability most. Its handling in crosswind conditions was exceptional, with precise rudder authority that allowed safe carrier landings in challenging sea states. This characteristic stemmed from the aircraft's optimal weight distribution and powerful control surfaces. Regarding aerobatics, pilots marveled at the Bearcat's roll rate, which exceeded 100 degrees per second, remarkably quick for an aircraft of its era. Additionally, the bubble canopy provided unmatched visibility, eliminating the blind spots that plagued many contemporary fighters. Test pilots consistently noted how the aircraft maintained stable flight characteristics even when pushed to its limits, inspiring confidence during complex maneuvers. The Navy selected the F8F Bearcat for advanced training primarily because it demanded precision while forgiving minor errors, the perfect combination for developing elite pilots. Its responsive throttle allowed instructors to teach energy management techniques that would transfer to both propeller and jet aircraft. Furthermore, the Bearcat's handling at both high and low speeds made it ideal for teaching the full spectrum of combat maneuvers. Students who mastered the Bearcat typically transitioned smoothly to jets, having developed the situational awareness and control sensitivity required for high-performance aircraft. Even as jets dominated frontline squadrons, the Bearcat remained valuable as a training platform that taught fundamental fighter pilot skills without the higher risk and operational costs associated with early jet trainers. Today, enthusiasts can witness the legacy of the F8F Bearcat at select museums and airshows around the world. These rare aircraft serve as living monuments to the pinnacle of piston-engine fighter development, allowing new generations to appreciate their historical significance firsthand. The Grumman Bearcat holds a special place in naval aviation history as the second demonstration aircraft for the Navy's elite Blue Angels Flight Demonstration Squadron from 1946 to 1950. Throughout this period, the team showcased the aircraft's exceptional aerobatic capabilities until their temporary disbandment during the Korean War. One particular Blue Angels Bearcat has had a remarkable journey. Designated Buno 1V176, this aircraft accumulated just 606 flying hours before retirement in 1957. Subsequently, it passed through several owners, including the U.S. Marine Corps Museum, where it remained in storage until 1996. Following a comprehensive restoration completed in 2005, the aircraft returned to the skies as N68RW, painted in distinctive Blue Angels colors. For years, it thrilled airshow audiences, often flying alongside modern FA-18 Hornets in dramatic displays spanning aviation eras. Currently, this historic Bearcat has found a new home with a European-based flying collection. Presently, only 22 F8F Bearcats are known to exist worldwide. Of these rare survivors, 6 reside in government-owned collections, with 4 preserved in Thailand and 2 in the United States. The remaining 16 are privately owned, with 15 located in the U.S. The United Kingdom hosts a particularly notable example, Grumman, a Grumman F8F 2P Bearcat based at the Imperial War Museum in Duxford. This aircraft regularly participates in prestigious events like the Summer Airshow 2023 and the Sywell Airshow 2024, demonstrating the Bearcat fighter's impressive capabilities to European audiences. Even more remarkably, Grumman represents the only airworthy F8F 2P variant and the only flyable Bearcat in the entire United Kingdom and European region. Thailand maintains another significant Bearcat presence. In 2008, one Thai Bearcat was restored to flying condition and occasionally appears at local air shows. Additionally, a retired example stood guard at the gate of Tekli Air Base during the 1970s, symbolizing the aircraft's important role in Thai military history. The National Air and Space Museum houses one of the most famous Bearcats, Conquest Wheat, which was donated to the Smithsonian in 1977. Visitors can view this historic aircraft in the aerobatic flight section at the Stephen F. Udvar Hazy Center in Chantilly, Virginia. Beyond static displays, airworthy Bearcats serve as dynamic links between aviation eras. The Bearcat aircraft's appearance at modern air shows creates a living connection to the transition period between propeller and jet propulsion. When these vintage fighters take to the skies, they offer spectators a genuine glimpse of the aircraft's legendary handling characteristics that made it a favorite among elite pilots. The Bearcat's enduring presence at museums and air shows reminds us that technological transitions are rarely clean breaks, as evidenced by how this ultimate piston fighter could still outperform early jets in several crucial metrics. Each surviving Bearcat thus represents not merely a historical curiosity, but a pivotal moment in aviation's evolutionary journey. So the Grumman F8F Bearcat represents a fascinating paradox in aviation history. It was arguably the apex predator of piston-engine fighters, a superprop that pushed the boundaries of performance with its unmatched rate of climb and blistering low-altitude speed. This excellence, however, was achieved through significant and sometimes radical compromises, including its limited range and controversial early wing design. The Bearcat was not a versatile jack-of-all-trades. It was a pure thoroughbred interceptor built for one critical mission: fleet defense. While it never saw combat with the U.S. Navy, the Bearcat proved its mettle in the hands of French, South Vietnamese, and Thai pilots. Yet its most enduring legacy may lie in the cockpit. Revered by legendary aviators from Neil Armstrong to Corky Meyer, it was celebrated as the ultimate pilot's aircraft, a perfectly balanced, responsive machine that continues to thrill audiences at air shows today. It stands as a powerful testament to an era when propeller-driven technology reached its absolute zenith just before the dawn of the jet age rendered it obsolete. Considering the rapidly changing nature of aerial warfare in the late 1940s, was Grumman's specialized hot rod approach with the Bearcat the correct strategic choice, or would the Navy have been better served by investing solely in more versatile multi-role aircraft like the later model Corsairs? We'd love to hear your thoughts in the comments below. Thank you, and we'll see you in the next video.